At midnight over Kashmir, nothing exploded. No missiles, no dogfights, no wreckage falling into the mountains. And yet, one side walked away unsettled. Four modern fighter jets approached contested airspace, believing the balance favored them. Minutes later, invisible systems were already tracking, measuring, and pressuring those aircraft, long before any pilot could see a threat. The jets turned back. No headlines announced defeat. No victory was declared. But inside command rooms, something far more important happened. Assumptions broke. This is not a story about who fired first. It's about why nobody needed to, and why the next India-Pakistan crisis may be decided before a single weapon is released. Public debate immediately focused on the wrong questions. Which jet is better? Which radar is stronger? Which country exaggerated its claims? Those questions are comforting because they're simple. They turn modern warfare into a scoreboard. But modern air combat no longer works that way. Today, air power is not a duel between pilots. It is a competition between systems of systems, networks that detect, track, coordinate, jam, and psychologically pressure the opponent. When analysts obsess over aircraft models, they ignore the battlefield that actually matters, the electromagnetic one. The most decisive actions in this encounter happened where cameras can't go. Long-range radar scanning, early warning aircraft feeding data to command centers, air defense systems mapping trajectories, electronic warfare platforms probing weaknesses. Together, these elements form an invisible web. If that web detects you first, locks you first, and forces your pilots to operate under constant electronic pressure, the engagement is already asymmetric. At that point, firing a missile is unnecessary. Turning back becomes the rational choice, not because of fear, but because escalation would be strategically irrational. That is the new face of deterrence. Military rankings dominate online discussions for a reason. They feel objective: speed, range, payload, radar type. But rankings assume ideal conditions. They assume perfect coordination, seamless data sharing, identical training standards, and fully integrated command structures. Real air forces don't operate in labs. They operate with mixed inventories, competing doctrines, software limitations, and political constraints. A jet is only as effective as the network supporting it, and in contested airspace, network cohesion matters more than individual platform performance. There's a persistent myth that buying advanced hardware guarantees dominance, but it doesn't. Technology, honestly, ages quickly. What really matters is integration speed and adaptation. Sensors must talk to shooters. Shooters must talk to command. And command must process data faster than the opponent. A gap at any point breaks the chain. This is exactly why two air forces with similar equipment can experience radically different outcomes. Not because one lacks technology, but because one lacks cohesion. And well, cohesion cannot be purchased off the shelf. Most failed missions don't fail because pilots are incompetent. They fail because command decisions create uncertainty, unclear objectives, conflicting rules of engagement, delayed intelligence. Pilots sense this instantly. And when pilots sense uncertainty upstream, confidence collapses downstream. In electronic warfare, hesitation is dangerous. Not because it leads to destruction, but because it exposes weakness. Once an adversary believes you are reacting rather than controlling, deterrence begins to erode. The absence of explosions creates a false sense of safety. Quiet confrontations feel stable. They feel manageable. But they're often more dangerous than visible crises, because thresholds become unclear. When no missiles are fired, no one really knows how close escalation truly was. Was it just one radar lock away, one misinterpreted signal, or maybe one automated response? Modern militaries rely heavily on systems that react faster than humans. That increases efficiency, but it also compresses decision time. And compressed decision time, well, it increases risk. Here's the part rarely discussed in viral videos. Air power is not sustained by jets alone. It is sustained by industry. Radars fail, drones are lost, electronic systems burn out under constant use. The decisive question is not who wins the first encounter. It's who can replace losses, upgrade systems, and adapt doctrine faster. Wars are marathons disguised as sprints. And industrial depth, honestly, determines who finishes. Many people still imagine air war as it looked decades ago. Dogfights, missile launches, spectacular footage. But future conflicts may offer none of that. They may unfold through persistent electronic pressure, drone attrition, information denial, and psychological exhaustion. Victory may not look dramatic. It may look like one side quietly choosing not to escalate, again and again, until strategic initiative is lost. This encounter did not prove who is stronger. It revealed something far more unsettling. Modern wars may be decided before the public ever realizes they've begun. And when control of the invisible battlefield shifts, missiles become optional, but consequences do not. That is why this moment matters, and why the silence over Kashmir may be louder than any explosion.